So here's the example argument that I want to work through, and I want to work through a formal proof of validity to show you how the formal proofs are done, and also to show you how the premises are connected using the rules of inference in order to reach the conclusion we want. So the example that we have is this one. The first premise says, if we want to send a manned mission to Mars, then it must either be funded by taxpayers or privately funded. So we would symbolize it like this. If we want to send a manned mission to Mars, then it must be funded by taxpayers or privately funded. The second premise says, we want to send a manned mission to Mars and other planets. So Mars and other planets. But I think that it should not be funded by taxpayers. So we would say not funded by taxpayers. Therefore, we need a manned mission to Mars that is privately funded. Okay, well, how do I get that conclusion from those premises? Look at what I have here. I have if M, then T or P, and then I have M and O. And notice what I'm doing here. I'm no longer thinking of the meanings. I'm thinking of just the constants themselves. And so if M, then T or P, M and O, therefore P, I've got too much here and too much here. In order for us to get to the modus ponens like it sounds like we need. I can get an M out of M and O by simply simplifying it. The rule of simplification says P and Q, therefore P. Here I have M and O, therefore M. So I took premise number 2 and I simplified it to get M. Now I have if M, then T or P, M, therefore, and you should recognize T or P as the conclusion. If M, then T or P, M, therefore T or P. Well, what rule is that? That's the rule of modus ponens. And I did a modus ponens on premise 1 and premise 4 in that order. So I write 1, 4, modus ponens. Remember that modus ponens says if P, then Q, P, therefore Q. And so I have if M, then T or P, M, therefore T or P. And notice that this Q here represents the entire proposition T or P. A single variable can represent a compound proposition like I have here. Well, I'm trying to get P. I have T or P. Notice I have not T here. And here's another trick. I'm on step 6. I've used steps 1, 2, and 4. I haven't used steps 5 and 3. And so I'm probably going to use them. And I'm going to use them in that order. T or P, not T, therefore P. This is the rule of disjunctive syllogism that says P or Q, not P, therefore Q. In this case, T or P, not T, therefore P. But notice the order I'm doing this one in. I'm doing premise 5 and then, premise 5 and then premise 3. And so I need to say 5, 3, and then I did a disjunctive syllogism to get that P that was desired. So now let's actually run through the argument in English. So again, if we want to send a manned mission to Mars, then it must be either funded by taxpayers or privately funded. We want to send a manned mission to Mars and other planets, and we don't want to raise taxes. We don't want it funded by taxpayers, so it must be privately funded. The first thing I did is we want to send missions to Mars and other planets, and I concluded that therefore at least we want to send a mission to Mars. I simplified it. And then we had, if we want to send a mission to Mars, it must be taxpayer funded or privately funded, and we want to send a mission to Mars. Therefore, it must be either funded by taxpayers or privately funded. And then I knew this, it must be paid by taxes or privately funded, and we don't want it paid by taxes. Therefore, it must be privately funded. That's the disjunctive syllogism. So we see that's how we work through the premises in order to reach the desired conclusion. And hopefully this shows you how formal proof of validity shows us how we can connect premises together, and it teaches students how to think in a straight line in order to reach our desired conclusion.